Alright everyone, welcome to the final lecture in the IUPAC naming session. So this is going to be purely a practice session, and if you guys are interested in more walkthrough or information, you can hop over to our website where you can purchase the guide or purchase a video content walkthrough for additional support of the channel. So let's go ahead and get started here. Number one, we want to identify and properly number the longest carbon chain in the following structures. So here are some structures that I provided. And the goal here, we will get to naming these, but right now we just want to identify the longest carbon chain and then number it in the proper way. So hopefully most people will be able to do this. With all of my practice videos, as usual, I encourage you to pause the video, attempt to do it yourself, and then come back and unpause it as we walk through it. So hopefully you had a chance to work on this. The longest chain is going to be from here to here for the first one. Now in terms of the numbering, we have to look forwards and backwards to see what's going to work best. So here we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 if we were going this way, right? So if I take a look at that, I'm going to just mark down in blue what the substituents would be if I was going the other way. So if I were to approach this the other way, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So I have a 4, 7, 9 versus, and then back to the red, versus a 4, 6, 9. And so the 4, 6, 9 is the lowering numbering system. The 4 and the 9s are identical. However, a 6 versus a 7 is going to matter. And so we pick out the lower numbering system. So the red numbering system, and because this is 12 carbons, we're dealing with a dodecane as the main chain. And then we would go through and we would name the substituents. That's going to be in the next question. So over here on the compound to the right, we have a cyclic compound. So what we first need to do is see if any of the chains are longer than the cyclic compound itself, because if they are, the cyclic compound will become a substituent. So we've got 1, 2, 3, 4 over on the right hand side of the molecule. So that's going to be butyl, and then we have an isopropyl. So neither of those are 6 carbons, and that means that the main carbon chain is going to be a cyclohexane. Now, what about the numbering here? Keep in mind that when we have a cyclic system, one of the positions will always inherently be 1. So I get to pick where I'm going to start that. I can start at any 3 of the substituents, but it's going to make the most sense to try to avoid this portion of the ring because there's nothing there. So I want to cluster it so that I get this portion with the best numbering. Now it should be fairly evident by looking at that we want 1, 2, 3, 4. That's the numbering that we're looking at here, and then you would have 5 and 6. Now why do we not start with the butyl? Because if it was 1, and again let's change this to blue here. It's a little bit easier to see in this example. 1, 2, 3, 4. Again, we have a 1 and a 4, but similar to over here, you're dealing with a 2 versus a 3 when you're dealing with that numbering system. So again, the initial way that we went about this with the red is what we're looking for. So we're going to keep this as a 1, 2, 4 numbering set. And that would be the answer for this. So, keeping that in mind, number 2, we are going to name the compound shown above using the IUPAC standards. So go ahead, I'll put this back up here in case you need it, and pause the video for just a second See if you can figure that out, and then unpause it when you're ready, and we'll move forward. All right, hopefully everybody had a chance to accomplish that. So, starting with the name for the one on the left, and keeping in mind we already have our numbers assigned up there using the red numbering system, we are going to be going for alphabetical order. So the two groupings, the two functional substituents that we have present on the first chain is a methyl, it's actually two methyls, and an ethyl. So E comes before M, so I'm going to list that. So the one on the right is going to be 6-ethyl. And then, like I said, it's a dimethyl because we've got two of them, so it'll be 4,9 dimethyl. That takes care of the substituents, and we already have the root name, so we would finish with dodecane. That would be the name for the first compound that we have up there. Right, now what about the second compound? The second compound we said was going to be a cyclohexane, and we have a substituent in position 1, 2, and 4. And the substituents are, in position 1, isopropyl, so we would file that under I. And then we have two B's, bromo and butyl. So bromo, because of Br, is going to come before butyl, which is Bu. So it's bromo, and then butyl, and then isopropyl. So following the numbering system, I'm going to have 2 bromo as the first one. And then after that, I would have 4 butyl, because Bu would be next in the alphabetizing set. And then -1 isopropyl. And I'm going to put this down here, but there wouldn't be a space in between it. Cyclohexane. That would be the name of compound 2. All right, so moving on to question 3. What is wrong with the following IUPAC names? 2-ethyl octane, 2,5-dibromo cyclohexane, and 3-methyl 5-ethyl nonane. So right off the bat, when you're looking at these, they sound like they'd be plausible names, but there's something wrong with each one of them. So pause the video, see if you can come up with a reason as to why these may be incorrect, and then unpause it when you're ready, and we'll talk about it in the walkthrough. All right, so hopefully everybody had a chance to do that. So starting with A, if we have octane, which I'm going to draw out here, 1, 2, 3, 4, 5, 6, 7, 8. And then we have in position 2, so here's 1, 2, we have an ethyl group. Okay, so what's wrong with calling this structure 2-ethyl octane? Well, the main issue that we run into here is that this 1 should really be the substituent, because this can be a continuation of the chain and it has 2 carbons. So instead of an octane, we should have a nonane, and the methyl should be the substituent, because we always go for the longest carbon chain. You don't pick out a shorter carbon chain and then have a larger substituent. So that is what is incorrect with A. Now, B, we have cyclohexane, and we have 2,5-dibromo. So 1, 2 has a bromine, 3, 4, 5. And then here's 6. So what's the problem with this? The problem with this is that we do not start numbering 1 in an empty position. We need to give it to a substituent. So we would really start numbering 1 right here at the bromo. And then it would be 2, 3, 4. It would be the same in reverse. It would be a 1, 4. So a 2,5-dibromo should really be a 1, 4. And remember, I'll cross this out. This should be a 2-methyl nonane, because it's a longer carbon chain, right? And this one, it's the numbering that was off. The dibromo cyclohexane is fine, but the numbering is off here, okay? And if you pay real close attention to C, you don't even need to draw this out to figure out what's wrong with this here. There is nothing wrong with the way that this is named, except we have an M before an E. So 5-ethyl and 3-methyl need a switch up in the naming. It should be 5-ethyl 3-methyl nonane, not 3-methyl 5-ethyl nonane. And this, a lot of students will get frustrated with an example like C. When they're on an exam, they feel rushed and they're writing it down and they forget to alphabetize and then they lose points. Many instructors will take off points because even though you have the correct structure, you have technically the correct pieces of the puzzle, you did not assemble them in the correct way. And that would not be the IUPAC standard. You have to pay attention to the alphabetizing, as annoying as that may be. All right, and then finally question 4 to wrap up the video here. How would the following compound be named? Now keep in mind, during this course, we did not specifically name functional group compounds. So we didn't start naming carboxylic acids. We simply talked about their ranking and how we would change the suffix, what we would change it to based on the table. So based on that, all I'm asking you is look at this compound. There's a lot of functional groups here. Based on all these functional groups, which one would get the priority in the naming? Would we name this as a ketone, an alcohol, an ester, or a carboxylic acid? So take a second to think about it. You got 4 of these. Okay, and the correct answer would be D. This should be named as a carboxylic acid. Carboxylic acids have the highest ranking in the group in terms of naming. Then it would be ester, then ketone, then alcohol. So if you go back and you look at the table that we discussed, carboxylic acids are ranked as the highest priority. And so this would be where I start my numbering from, 1, 2, and then I continue going all the way through this, and the rest of these would fall in line as separate functionalities, not as the main parent chain. All right, so that is it. That concludes everything for the IUPAC learning course that we're offering here on YouTube. Again, I encourage you to go over and support the channel so we can keep bringing you quality content. If you're interested in purchasing an e-guide or the longer walkthrough video for more problem-solving content, you can check out our website for more information if you're interested in private tutoring or any other type of information about what we offer. And just remember to like and subscribe and leave a comment if you found any of this helpful or if you have questions that need clarification. So as always, thank you for learning with us, and we will see you guys in the next online course.